Hello, welcome back to my channel. Today I am going to start a series of complex analysis, and this is very useful for all Btech branches and for MSc, BSc, and as well as for any programs. This part complex analysis is very useful. So I had prepared a notes for this, and I will explain one by one. We are starting from the basics. What is the basic of a complex analysis, which is the complex number, isn't it? The complex number is the very basic part of complex analysis. Then we move on to the advanced part. Okay, now what is a complex number? How we can represent a complex number? A complex number has got two parts. So complex number can usually be expressed as z is equal to x plus iy, where x is called the real part, and y is called the imaginary part. Okay, y is called the imaginary part. But then you can see an I here. What is I? I is equal to root of minus 1, isn't it? I is called root of minus 1, or I squared is equal to minus 1. But this is the usual expression representation of a complex number. Z is equal to x plus iy, where I is equal to root of minus 1 and I squared is equal to minus 1. And the next part is the complex number can be usually expressed in a diagram, and such a diagram, complex number can be usually expressed in a diagram, and such a diagram is called the Argand diagram. Okay, it is called an Argand diagram, which you can see in my notes. The Argand diagram, using an Argand diagram, a complex number is represented here. See, suppose x and y are the real and imaginary parts. The line OP represents the line z equal to x plus iy, and theta is an angle which makes an angle theta with the x-axis. And here you can see that r is equal to, suppose z is equal to x plus iy is the complex number, root of x squared plus y squared, which is equal to r. So which is called the modulus. And here one more is there, theta is equal to, you can see here, theta is equal to tan inverse y by x is called the argument of z, and is denoted by argument of z. So this is the way a complex number can be expressed. And you can see that the polar form of a complex number is z is equal to, polar form of a complex number is z is equal to r into cos theta plus I sin theta, or otherwise cos theta plus I sin theta is e raised to I theta, so that is r e raised to I theta. This is the polar form of a complex number. Now there is one more thing we have to discuss. The another concept is, suppose z equal to x plus iy, then it's a conjugate of the, then z bar, the conjugate, which is called the conjugate of a complex number, And what is a conjugate of a complex number? It is nothing by just changing the sign of an imaginary part. If z equal to x plus iy is the complex number, then z bar equal to x plus x minus iy is the conjugate of a complex number. So for example, suppose z is equal to 3 plus I into 2. 3 plus I into 2 is a complex number, then its corresponding conjugate is z bar is equal to 3 minus 2i. Okay. Now I already told you, suppose the modulus of z is called modulus of z. You can calculate the mod z is equal to root of x squared plus y squared. Similarly, the modulus of z bar is equal to root of x squared plus y squared. How you getting this modulus of x square plus iy square, isn't it? Iy square. So what happens? Z bar is minus iy. Okay, z bar is minus iy square. So here also we get x squared plus y squared. That means the modulus of z and is equal to modulus of z bar. But the modulus of the complex number and its conjugate are always equal. The modulus of a complex number and its conjugates are always equal. And there is one more thing is, suppose mod z squared is equal to z into z bar. Okay, mod z squared is equal to z into z bar. How are we getting this? I already told you mod z squared is equal to x plus mod z squared is equal to x squared plus y squared. Now you calculate z into z bar. Z into z bar, what is z? Z is equal to x plus iy. What is z bar? X minus iy. Just multiply this. This is a plus b into a minus b format. What is a plus b into a minus b? A plus b into a minus b is equal to a squared plus b squared. A squared minus b squared, isn't it? A plus b into a minus b is a squared minus b squared. Like that, what we get here? X squared minus iy whole squared. Okay, so we get x squared minus I squared is minus 1, minus 1 minus is plus, so we get x squared plus y squared. So mod z squared is x squared plus y squared. Z bar is equal to x squared plus y squared. That means mod z squared is equal to z into z bar. Thus we obtained this result. This is one of the result here. Now one more thing we have to not one more thing, many things we have to discuss here. Suppose the next concept is, suppose z is equal to x plus iy and z bar is equal to x minus iy. What do you get when you add z plus z bar? Z plus z bar, you get x plus iy and x minus iy, isn't it? So we get 2x, right? So x is equal to z plus z bar by 2. Okay, similarly you can calculate y. What you will get y? That is z is equal to x plus iy, z bar is equal to x minus iy. Okay, so to get y we have to subtract, that is z minus z bar is equal to iy minus of minus iy, we get 2iy, isn't it? So what you get y is equal to z minus z bar by 2. See, now you can express zx, the real part of a complex number and the imaginary part of a complex number, in terms of z and z bar. That is, x is equal to z plus z bar by 2 and y is equal to z minus z bar by 2. Okay, so this we can say that x is equal to real part. X is real part also, so you can denote it as real part of z is equal to z plus z bar by 2. Similarly, y is imaginary part of z, so imaginary part of z, im of z is equal to what you get, z minus z bar by 2y. These are two important concepts here. Now here we can see another, a pair of complex numbers x plus iy and x minus iy are conjugate of each other, isn't it? X plus iy, the conjugate is x minus iy. And suppose x minus iy, when you ask what is the conjugate of x minus iy, just is change the sign x plus iy. So x plus iy and x minus iy are said to be conjugate of each other. Now the sum and product of a complex number and its conjugate are always real. So let us see. Suppose x plus iy is a complex number. X plus iy is a complex number, and x minus iy, its conjugate. Suppose z equal to x plus iy, z bar is x minus iy. So when you add z plus z bar, what you get? X plus iy, plus x minus iy. So what you get? X plus iy plus x, iy and iy get cancelled and you will get 2x, that we already discussed here. So it is real. The sum of a complex number and its, that is what I written here, the sum of a complex number and its corresponding conjugate is always real. Similarly, when you calculate the product also, you can see that x plus iy into x minus iy is x squared plus y squared, so that also real. So addition and subtraction, how you add one complex number with another. Suppose x plus iy is one complex number and x1 plus iy1 is another complex number. iy1, x1 plus x1 plus x plus iy, comma x1 plus iy1 are any two complex numbers, then their addition, how you can add two complex numbers, you should add the corresponding real part together, x plus x1 plus corresponding real imaginary part, that is I into y plus y1. See here, x plus x1 plus I into y plus y1. Similarly, subtraction, you can see that suppose you take any two complex numbers, a plus ib minus c plus id, what you get is the real part is a minus c plus I into b minus d. Similarly, multiplication a plus ib into c plus id, two complex numbers. Whenever you multiply, write the real parts together and imaginary parts separate. So real part is ac minus bd plus I into ad plus bd. Similarly, division a plus ib divided by c plus id, what you get? So in this case, you take multiply the numerator and denominator by the conjugate of c plus id. What is the conjugate of c plus id? C minus id. So a plus ib into c minus id divided by c plus id into c minus id. Whenever you multiply the entire thing and separate the real part and imaginary part, you will get the answer like this. Direct multiplication, nothing is there. Direct multiply, and you will get ac plus bd by c squared plus d squared is the real part, plus I into bc minus ad by c squared plus d squared is the imaginary part. Now the next thing is, two complex numbers a plus ib and c plus id are equal whenever the real part are equal and imaginary part, and whenever the corresponding real part equal and imaginary part equal. That is a plus ib equal to c plus id. So take the real part one side and imaginary part other side. So what you get? A minus c equal to I into d minus c. So which implies square both sides. We get, in order to avoid this I, we get a minus c square is equal to I squared is negative 1, that we will get here negative of d minus b squared. So what you get? Whenever a minus c square plus, you can take the d minus b this side, you get a minus c square plus d minus b square is equal to 0. So this is the another concept. Now we have the sum of two positive numbers is 0. That is, this is only possible when a equal to c. That is why, and b equal to d. So that is what we wrote here. Now we have express this complex number. This is a problem. Express 1 plus I into 2 plus I divided by 3 plus I in the form of a plus ib. So how you can represent this entire thing in the form of a plus ib? What you do is, first you multiply 1 plus I into 2 plus I in the numerator, and 3 plus I you just leave it as it. After multiplying and simplifying, the numerator you get 1 plus 3i and denominator is 3 plus I. Now what you do is, you multiply the numerator and the denominator by this. You can see here the conjugate of 3 plus I, that is 3 minus I, 3 minus I both sides, and multiplication, and after simplification you will get, you can see here directly, 6 plus 8i by 10, and simplification we get 3 by 5 plus 4 by 5 into I. This is the answer. I will repeat once again. Suppose this is an expression and this is a complex number, then you can express in the form of a plus ib by simplifying. So in order to simplify, first you multiply the numerator each and every term, and after simplification you get 1 plus 3i and divided by 3 plus I, and denominator is 3 plus I. So multiply its conjugate with the numerator and denominator, that is 3 plus I, the conjugate is 3 minus I and 3 minus I. After multiplication and simplification we will get 3 by 5 plus 4 by 5 into I. This problem also you can do as a you can just check or try it as a homework. What is the expression? 6 plus I into 2 minus I by 4 plus 3i into 1 minus 2i in the form a plus ib. So multiply, after multiplication and simplification you will get the answer like this. First you multiply the numerator and denominator each and every term. So after simplification we got 13 minus 4i by 10 minus 5i, and after getting in this version, in this form, you multiply the conjugate of 10 minus 5i, that is 10 plus 5i in the numerator and denominator, and simplification you will get 6 by 5 into 1 by 5 into I. And with this concept I am stopping for now, and I will come with another video. This must be the continuation of the, that video should be the continuation of what we of this video. So if you like my video, please do like, share and subscribe. We will see you in the next class, next video. Till then, bye bye, take care.